I'll go ahead and get started. I just would like to welcome everybody. This is our September edition of our webinar series that we've been doing. And we welcome all. We welcome our representatives throughout the world, our existing customers, probably some potential customers, and anybody else who's interested in learning about the topic for today. The title is Centralized Real-Time Traffic Analysis over Wireless IP and TDM Networks. So the focus today will be on GL's extensive protocol analysis testing suite that we have, as well as a product called Net Surveyor Web. So we're excited to present this to you. This is an area that GL has had test equipment in for many years, and we've constantly been updating our suite of protocols and features within our protocol analysis systems. So we're excited to show you some of the latest features with that. Again, my name is Matt Yost. I'm here at GL Communications, and I'm joined today with an expert in this area. His name is Savan Kumar. He will be helping along the way here during a portion of the presentation. So we'll go ahead and get started here. Just to give you a little bit of background on who we are, if you're not familiar with GL, we're located in the US in Gaithersburg, Maryland. We've been around since 1986. We do a lot of consulting engineering work for local, state, federal government, transit agencies throughout the East Coast here. And we have a very full-ranging test suite of test and measurement equipment, catalog of test and measurement equipment. We've been in the test and measurement equipment business for many years, since the early 90s. So we started out in the TDM world, T1 testing cards and so forth, with a variety of software to run on those. And we've now moved obviously into wireless, the cutting edge wireless technologies, as well as IP technologies. So we've got a full range of test equipment. For today's agenda, as I mentioned, Savan will be helping me. He's going to probably take on the first three bullets here, which is, getting into the root of our capture software, which is capturing it, these different protocols that are listed below here. That will be shown sort of the core capture capability that we have at each probe location, we'll call it, where we'll see call detailed records, ladder diagrams, protocol decodes. He will also be showing you how we show statistics and reports on that signaling, as well as the traffic at each probe. So you're going to be able to look at the voice traffic and calls of interest, trigger on different calls of interest that you may have. So he's going to show you a lot of that localized testing suite that we have there for the capture side, as well as the display side, where you can look into the protocols and see the voice traffic and so forth. We'll get into, and I'll probably pick back up at this point when we get into historical data. So all these capture probes that we have, and we'll get into it a little bit more here. All of these capture probes can be funneled into, their traffic can be funneled into a database, and that database can be mined by a web client. And we call that sort of whole area there our Net Surveyor Web product. We'll get into exactly how that complements our protocol analyzers. So to get started, we'll jump right in here. I'll be again handing to Savan here in a minute, but I'd like to just give you an overview of the network and the architecture and how GL sort of plays a role here. As you can see, this is a very extensive network with many different protocols and many different test or mediums for traffic, carrying traffic and so forth. So TDM network on the top left, as you can see, traditional. We've got the new wireless protocols that are going on here, as well as IP. GL, if you're not aware, GL has protocol analysis products in all of these areas. Okay, so In the wireless area, we cover all of the wireless protocols the predominant wireless protocols that you may have. Back in the TDM area, we have all of the previous CAT, from CAS to ISDN PRIs to SS7s and so forth. So all of these protocols, some of which may require a piece of hardware that we offer as well to tap onto the network, tap onto the circuit. But we have all that, and then we have the protocol analysis test suite to go on top of it, and gives you decodes of all these protocols, as well as we marry in the traffic. So the voice, the data can be shown as well and organized with these calls. So that is all carried over, of course, to the latest and greatest in the IP world and voice over IP with SIP and RTP traffic and all of that, MEGACO, SIGTRAN, and the rest, H.323 and so forth. All of these probes that we're showing here can, as I mentioned previously, can be capturing individually, and a technician and engineer can be sitting there at that location monitoring on that particular node or probe level, and they can get plenty of information right at that level, right at that single sort of local level. They can also deploy these throughout their network, and they can start capturing at these different locations and funnel all of that information back to this database that we have, a centralized database. At that point, all of the information is stored for historical record keeping and so forth, and that information, that database, can be mined and looked into and grabbed out. You can grab out information that you may want to see at any particular time, and that would be served up by a web server. So any web client that you may have, PC or smartphones and so forth, can look into this database and figure out some events of interest, some network statistics, and so forth. So all of that's sort of our overall architecture to how we do things. We have what we'll call a probe level capture probe, which has the ability to do a lot of analysis just right there at that probe level. Or we have this centralized database option, which will allow you to historically store all of this information, and then that can be presented to technicians, engineers, and so forth, network administrators. So that's how we set that up. One more slide to kind of go into a little bit more detail at the probe level here. So at the probe level, at an individual sort of test point within your network, depending on what protocol you're looking at that particular test point, our testing equipment basically consists of a few different parts. We'll call it a call capture and analysis component there. So there's a hardware component at times. So if you are on a traditional T1 link or a monitoring traffic over a OC-3 or a fiber link or something like that, we have the associated hardware to tap in and monitor that. And then we have the software, the protocol analyzer and the packet data analyzer software to read that and display that information. So look at that protocol in a lot more detail, look at that traffic in a lot more detail, sort of understand what's going on, look at trends on the network, and so forth. So the components that we have here within our software package are the protocol analyzer and the packet data analyzer. The packet data analyzer, and I'll just say the protocol analyzer is basically what you would traditionally get if you're familiar with like a Wireshark. So you get all the frames coming in, you get the display of the raw frames, the hex dump, the protocol decode, so the plain English decode of that. The beauty of our product is within this packet data analyzer. So this packet data analyzer has a way, we call it the PDA for short. It has a way of organizing all of the gudge that you're bringing into this product. So all of those frames are just hitting us, hit the front door, and many, it could be hundreds of calls simultaneously happening there, of course. So we organize those calls, we organize all of that data, and we display it in a very friendly manner here in our packet data analyzer. So we organize by call, by protocol, and so forth. So with that, it goes even beyond that, a step beyond that, and it starts getting into the traffic. So the calls are organized as the to, the caller, the callee, the date, the time, whenever that call happens, sort of the CDR view. But then one level below that, you can start looking into what traffic is on that call. So if the voice is going in both directions, you can listen in real time on that call. You can record that call. You know, these types of things are all available within this packet data analyzer, and they're available for all of the protocols that we're going to show you here. So the key here that I'd like to point out for some people that probably are familiar with how GL has done their our protocol analysis in the past is we've got the same sort of look and feel of what we've had, so we haven't changed that, but we've been now adding some things to this PDA. You probably have never seen our ISDN PRI protocol analysis system have the ability to, right from that protocol analysis screen, have the ability to listen to the traffic. There may have been other modules that we had within our cards and so forth, but now it's all been centralized sort of at that PDA portion of our software. It becomes a very complete solution at each probe. Complete solution, signaling, all the protocol decodes, the CDRs, and then the traffic. All of it's right there at one glance. You can take a look at it, and we'll show you that. So that's sort of the overview of what we're going to be getting into. The new things on top of our protocol analysis that we've had for years is this PDA expansion that we've been doing here. Okay. So now what I'd like to do, I'm going to bring Savin in. He is an expert in the protocol analysis and the different protocols that we offer, and you can see there's a whole slew of them here. And he will take over for a few slides, and then I'll jump back in. Go ahead, Savin, if you would.
Thank you, Matt. Hi everyone, and welcome again to the webinar where we are presenting one of the most powerful telecom testing tool, which we call as a packet data analysis, which has been explained by Matt in the previous slide in a very detailed manner. So let's see how it is powerful and how efficient it is to analyze and produce the results for the users. So as we have seen, we have the ability to capture and decode the frames from different network nodes like wireless, IP, TDM. So we have few protocols listed here. These are very few which are limited here. Like in the TDM world, we decode ISDN, LabD, SS7, CAS, all these protocols. Then when we move into the WIPE, we have the capability to decode SIP, RTP, then SIGTRAN, then LTE, IMS. So we have a bunch of list of protocols, even apart from this very huge list of protocols which we support and decode, and we produce the results in a user-friendly manner. So with this detail, let's quickly move into the application and see how it looks like and what kind of results it produces. So this is the basic protocol analyzer main GUI, wherein you see live capturing and the details in different views. In the first, we have like summary view, wherein we are displaying all the captured frames at like a timestamp and what kind of traffic it is, what kind of frame it is, from which port it has been captured, and where it is addressing, what kind of payload it is carrying. So all this bunch of details is displayed for all the frames in the summary view. Then right below it, we have a view called detail view, wherein we display the entire decode information at the layer wise and IE information of entire packet or the frame. Then right next to it, we have an hex dump view, wherein we display the byte information of entire packet or the frame. So you just select the frame and you get all the information right below it. Then we have a call data record view here, wherein we display a very limited or the brief description of a call at the call level. So first three views displays the frame level information. Then we have a call data record view wherein you get the information at the call level, like for example, the call data, call duration, card start time, what kind of call it is, whether it has been completed, terminated successfully, got a failure call. So all this information you will get in here. So this is the basic important features we display within the main GUI itself. User don't have to go in some other views and do some settings, extra settings here to get. So let's see how easy it is to configure with the to get the details. The user is also, the user configuration needs to be very user friendly. So let's see how easy it is to configure these probes. So you can see two different views here. Like we have an option to select the Ethernet cards wherein we can capture IP and wireless frames. You can just select the required Ethernet probes and you can able to start capturing the frames. You can select even multiple probes if the multiple Ethernet cards, if the bandwidth is allowed, then you can capture any kind of protocols. It might be a single WIPE protocol, or it might be a different network nodes also. Let it be WIPE, wireless, or whatever. So you can do multiple protocol capturing with the single probe. Then moving into the TDM capturing, we have a bunch of selection options here to get a good frame into the protocol analyzer. Like to say, you need to select the time slot, then you need to select what date at what data rate you are getting those analyzer frames. Then you also need to say what kind of CRC you are getting into that particular frame. Let's say 32-bit CRC, 64 none, whether the bits have been reversed or inversed. So you have all these options, so you can select and go accordingly to get a good frame on this. Then quickly moving into it, to get a good frame, you need to do a protocol standard selections. Let's say, for example, when going across ISDN, we have a bunch of flavors protocol standards like Q93, 4ESS, 5ESS, Bell, ISDNs. So we do provide all these protocol standards and can decode and provide you the information available for all the protocol standards well defined by the standards. We'll be moving into one more important feature which is provided at the capture level, and we call it a filters. So filters we divide in two mans here. One is the capture filter, the other one is the view filter. Capture filters offer you the call of or the frames which you are interested in to capture only those frames. Like for example, if your Ethernet interface is carrying different protocols, let it be LT frames, RTP frames, TCP, UDP, all those frames. But if your interested frame is only on SIP side or on the IP RTP side, so you can select that particular protocol filter and you can start capturing it. It will discard all other frames and discard only the interested filters. Then we have a filter called view filter on the right side, you can see. So this is helpful when you capture the frames and when you have some SIP calls and you are interested in seeing only the invite messages within the captured frames. So this is an example there explained, but if you can do the view filtering at the IE level, the protocol can provide you. You can select any protocol and all the IEs can be used for filtering. So those are the few capturing options, filter options we provide with our tool. So with these filtering selections, we move directly into the packet data analyzer, which is the real hero of the webinar. So in the analyzer model, we have seen like the information at the frame level, we capture and we provide informations on the frames like summary view, detailed view, hexagon view. Then with those details, we are moving into the, you are taking that data into the packet data analyzer, wherein we provide extensive results like ladder diagrams, decode information, RTP analysis, uh, RTP analysis in a numerical values as well as in graphical manner, and we can play and capture the audio files, audio present in that particular calls. Then we can even extract the facts if the traffic is carrying in it. Then over and all these things, yes, we can do triggers and actions which are very important features, like say when you have some millions of calls together and you don't want to go through all those calls, your call of interest area is very limited. So you can do that filtering using the triggers and actions options. It can capture only those calls. It can bring you out of those from millions of calls. You can take out that one call and it gives the result for that one call. So let's see how the PDA looks like and what detail it provides for you. So this is the main packet data analyzer GUI, wherein it provides some summary results on both the signaling and RTP level. So in the summary view, you can see the pink lines like caller calling information is provided in here, and very limited information like call start time, call duration. So this GUI is restricting the results to very limited manner. If you scroll down or scroll right to it, you have a very large information available here, like at what duration, whether the call has been established or not, whether the call has been answered or not, for what reason call has been terminated. So you can see all those information in these columns. Again, these columns are very easy and easily user configurable on any IE available for that particular protocol. Then you can also see the RTP analysis provided for that particular call, related to that particular call right below it, on both the east and west traffic. What kind of codec it is handling, what are the received packets, what is the MOS score, what is the R factor it is available. So these are all information very important when you are analyzing the RTP. So these are the MOS score or factor will help you analyze the voice quality or the traffic quality your interface is handling. Then going further, it also gives you the active call graph, wherein you can see what number of calls it is the network is presently handling, what number of active calls it is handling. Then right next to it, we do provide information on the probe level, wherein we give statistics of all the calls. Let's say if your interface is carrying different protocols like SIP, ISDN, PRI, or the SIGTRAN, or the WIPE, any protocol. So all those protocol statistics will be given right here. Then if you are interested in some particular protocol like say SIP, you just need to select it from the tab available over there, and then it will provide the call details or the message information, statistics of the messages related to only SIP calls. Let's say like active calls, first call, fail calls, out of frame calls, forced close calls. All this information is available in the statistics window. So this is the basic information which is segregated into the main GUI itself. User don't have to go into some other configurations and get access. You have bunch of tabs you can see right below it. You have a lot of data available in there, and you just need to select the tabs and the data is available right there. Let's see few more options available in the PDA. This is the one more tab available in the main GUI itself. We call it as a call graph. So you can see the call information is how easily it is available in a ladder diagram in just a click. So you can see the entire messages related to that particular call, and you can see the timestamp, you can see the frame numbers, you can see the port numbers, you can see from which IP to which IP that message has been carried, and what kind of messages call flow that particular call has been gone through. And when you select some particular message within that protocol, the entire decode information, including the signaling and RTP information, is available right next to it. So that's how beautifully it is segregated all the information into the main GUI. Over all these informations, we provide few standard filters on the probe level. Let's say like active calls. If the user is not interested in the call, all the calls captured by that probe, and he is interested in like failed calls or the voice calls, video calls, that can be done using the standard filters provided in the application itself. Just select from the drop down list what kind of filters you want, and you will be able to see only those calls. So with that's about the signaling and RTP statistics. Then moving into the graphical analysis, we have few graphical reports in here, like say average jitter buffer, R MOS, R factor, MOS factor, packet discarded. So all these information is analysis has been done at the probe level. You can do an analysis at the probe level, you can do analysis at the call level. All this information is available right next to the one after the other tabs. User just need to select what kind of traffic, what kind of information, what kind of statistics he want from the tabs available over there. So that is at the probe level. Then we have the options to dig into the RTP of that one particular call. Like the entire RTP information of that particular call is given in the detailed view. So in here you can see what is the RTP marking, what kind of RTP it is handling, RTP sequence number you can take, what kind of codec it is handling, whether the RTP packets are in sequence or they are out of frame. So all this information, SSRC information, source IP address, destination IP address, and few RTCP senders reports. So all this information is available at the call level. And when you see right at the bottom, you have bunch of tabs again in here. Even at the individual calls, you can get all those information, say gap graph, jitter distribution. So all these informations are available in a very easy clicks. So then moving into few graphical statistics at the individual call level, we do provide graphical statistics at the of the jitter buffer statistics and gap graph of the audio file. So all this information is available. So then we do provide information like wave and spectral graphs. So you can see the live traffic and the power level of the voice carrying over. Then we have, like as explained, we have few important features like triggers and actions, which will be very helpful when you want to save calls or track some users using the caller callee numbers. So all these, and if you want to know the MOS score calls which are dropping below the expected level, so you can track all those calls. You just don't track all those calls, you can have some alerts also, do some actions also, like to say when you have a calling party identified, so you can do the actions like you can inform the users that send a mail, you can pop up a message that some user has been active on the call, and when you say on the IP side you have a MOS score application. So all this information and triggers can be done using triggers and action options. It's not only limited there. Once on capturing and analyzing, you do have option to export all these results. You can export it to CSV files. You can write the signaling information, RTP information into CSV files, or you can explain it to database, which will be next explained by Matt. But in here we have that option to export all those signaling informations, let it be any protocol. And you also have the option to uh, write the traffic to some particular call. So then quickly moving into the application, after the application informations, let's see how useful the application is apart from capturing and analyzing these different protocol standards. So one of the user had an issue with their router and gateway wherein their calls were getting delayed, and they had observed the issues like crosstalk between the calls. So they wanted to identify the delay in the network. So what we have done is we have given the PDA solution for them, wherein what we do is we capture the traffic, TDM traffic or the wipe traffic, which is traveling through the gateway router all the way to the other side, from TDM to IP and IP to TDM. So we do capture both the side traffic. Then we, with the timestamp analysis, we provide the delay measurement for the user, which will be helpful to identify the delay at different levels. And to make sure it works fine at the very finest accuracy, we do have used the application like Packet Expert, which will be helpful, which is GL's product, wherein this helps in introduce the network impediments like delays. I'll bring here Matt Yost, who will be explaining how we store the data to the database, then how we access all these results using the web client application NetServer.
Okay,
Matt?
thank you. Yeah, Savin, thank you very much. One thing I will mention about the previous slide, this is a sort of new idea that GL has. I wouldn't say a new idea, but it's a new offering that we've had, and it's getting some interest. And that is, you know, if you're on two sides of a gateway, which is what Sabin was mentioning here, we can take our protocol analyzers on the TDM side and another one on the IP side, and we can do some very precise timing between these messages to figure out the timing between, you know, when those messages are received at each location through the gateway. So, you know, a gateway manufacturer, a gateway, somebody's responsible for the gateway and for the timing through the gateway. If there's issues, we can be brought in with this little test suite here, where with a protocol analyzer on either side of that gateway, and we can get very precise timing. So something that's been added to our repertoire here fairly recently. So what I'll get into now is, and to sort of get things moving a little bit, we're at the tail end of what we're presenting today. Savin, just to recap, Savin gave the details of what happens at this capture and packet data analyzer level of our hierarchy, of our architecture. So at the, I usually refer to it as the probe level. So at the probe level, we're sitting there capturing, and then this packet data analyzer, the PDA, which is the screenshots and all of the information that Savin just presented, is available, and that is localized. That is very attractive for technicians that go out into the field and to troubleshoot a situation on a circuit or on a data line, something like that. They can take that into the field with their laptop and this software and capture and diagnose right then and there. It's very useful for lab engineers and technicians who are trying to troubleshoot issues and just verify things are working correctly with maybe equipment manufacturing, you know, research and development labs that are manufacturing equipment that have to handle these different protocols. So all of that is, I'll call it at the local level, some of the views you get from the local level right there, right then and there at the capture point. Now, the next sort of level of our architecture with all of these is we can have protocol analyzers at the probe level feeding a database that can be centrally located. And I will explain a little bit more about how we can sort of marry those two together with what we call our Net Surveyor Web Lite. But at the moment, I will explain that at protocol level and at the capture level, these can be deployed at different points in the network, multiple points, and all that information can be sent back to this database And then at that point, we have the information and we can look at the database. So I'm going to be showing you sort of what's happening down at this level here. So this is at the far point in our architecture where we're storing data, we're storing these captures that have been made at multiple points in your network, and now we have that data stored historically, and now we can mine that database and show you sort of what views and what features we have at that point. So that product, that database and that web server and the mining of the database, that's all referred to at GL as our Net Surveyor Web. So just to quickly go over that, I won't spend too much time on all the wording here, but it can be used in real time, or it can be used to look back into the past, so historical data. You can be looking, and the real-time application is very useful as well. I should mention, I've mentioned a lot about historical data and archiving, but in real time, you can be seeing things pop up in your network at this database level. So it is a real-time application as well. It provides a lot of things that you've seen at that probe level. So you can look at the CDRs. You can look at ladder diagrams. You can look at the protocol decode. You can look at the hex dump if you want. So you can drill down extremely low into what you may want to look at on a particular call, on a particular message of that call. But it also gives you the ability to sort of take a very 30,000 foot perspective on your network. So you're looking at multiple probes here, and you want to kind of know what's going on sort of at a network level. It can give you that too. So we call those key performance indicators. So it has plenty of KPIs that can give you network level statistics, I'll say. How many calls are currently active in your network? How many calls happened, yesterday between 5 and 6 p.m. in your network? What has been the MOS score of those calls that happened between 5 and 6 p.m. in your network? So the sky's the limit. Whatever you can dream up, I'm sure we have available within this Net Surveyor Web. And the reason I say that is, if it's not available in the standard offering, which is a lot of KPIs, it's SQL driven. It's very easy for a user to create a KPI on the fly. We give you all of that access. It's very easy for a user to call GL and ask us to create one that may be a little bit more complicated than you're comfortable doing. So all of that is available within this. The data is in the database, and it's just a matter of accessing what data is interesting to you. So that's what this Net Surveyor Web is. We have and I'll get into this a little bit more with one slide, but we have a sort of full version of the Net Surveyor Web, and we also have a Net Surveyor Web Lite version now. And I'll tell you about the differences there. The feature sets are the same. It's more of a how much data are you capturing? Do you have multiple probes? How many multiple probes? Things like that. So the feature set is the same. So just a couple screens here I'd like to go through, and I'll do this fairly quickly. I wanted to explain sort of the architecture and what the applications were for Net Surveyor Web, and a little bit more clarity there, and I think I've done that. But now I'm going to show you a few of the screens. Just one thing of note here is we're just showing a couple screens. We're popping up a couple screens here to show you. Net Surveyor Web has user access, admin access. Admin can control user access. You can set up all of your privileges and so forth. So Savin, as an administrator, could tell me as a user that I only have access to do certain things and to look at certain probes, or to configure certain things. So there's all types of things there that can be restricted. Admin, of course, can do whatever they want. So I just wanted to point out that we have that sort of built into the Net Surveyor Web. It's all standard things that these types of products have these days, but we have that. This is the main screen, I would say, for sort of just a good overview of what this Net Surveyor Web looks like. It's a web-based product, so you bring up a web page, and you can see here that This screenshot shows myself as a user. So I'm logged in, and I've got access to whatever the admin has given me access to. There are, just to go over this a little bit with you, there's sort of four sort of tabs here that you can click on. There's a data tab, which is being shown now, and that's a very similar view to that CDR view you were seeing in the packet data analyzer just a few slides ago with Savin. So that's organizing everything in a per call basis. Okay, so I'll stick on that just for a minute, but even with that, you can do filtering on those CDRs. You can show CDRs from a certain time frame to a certain start time and a stop time. You can search different things within indicators of the CDRs that you're looking for. Maybe you only want to see CDRs from one of your probes out of 6 that you have out there at any given time. Maybe you want to see do a search on a particular phone number or a particular IP address. All of that is possible. It's built into the software, it's built into the application, so that filtering is all there, I would say. Now, what do you get when you look at it? Here's just a pretty simple, this is you can see here on your protocol type on the top right. This is a VoIP protocol, it's SIP and H323. So we're showing a SIP call here. It's coming from a SIP probe, that's a name that you've given it. This particular call is from 0003 to 0003 at different IP addresses. So it happened at this time, that duration. It's giving you the MOS score in the direction, each direction. And even down below here, when you click on the plus sign, you're seeing the east, we call it the east and west direction of that call. So it's a PCM ULAW call, total packet count, missing packet percentage and count. All of the statistics that you may want to see. If I were scrolling over to the right here, you would see jittered packets, MOS scores, all of those things that you saw back on the PDA are available here. All those statistics are sent to the database and we have them. So that's sort of an overview of what this data tab shows you. Again, we've got some niceties built into our software where you can see all called, failed calls, whatever you deem as a failed call, poor MOS scores. You can set those thresholds, those types of things, all available right out of the box. We can customize some of these things as well with SQL reports and so forth. So if you would click on the reports tab, which I think we're going to show quite a few screenshots here shortly, but this is where you're getting an overview of the network, I would say is the main feature with it. You can also do reports on some specific things if you'd like, but typically the reports that I've noticed our customers using are generally overview of the network, maybe how many calls are going through different points in their network, those types of things. I'll show you a little bit about alarms as well, but you can set up alarms here. You can set up the software to be looking for, I'll call them events of interest. You can sort of dream that up as well. I'll give you one example on that. If my MOS score, goes below a certain threshold that I've set on 3% of my calls, then I want to be alerted of that immediately. And I want to be alerted of that through my email or through a text message or something like that. Those are the types of things that can be set up here. If a probe is seeing an exorbitant number of calls flowing through it, and you've set up that threshold, I want to know that. If it's seeing a low number of calls going through it for some reason, I want to know that. So things like that are available within this alarms. As I'm moving forward here, this is showing a little bit more detail on what I had mentioned earlier. On a per call basis, you have all of those details that you would want and that you had seen Savin show you in the protocol analyzer and a packet data analyzer. So again, ladder diagrams are being shown there. When you click on the message, when I click on the invite, it shows you the full plain English decode. Okay, this is a summary view of the of that particular call. It shows the invite, trying, ringing, so all the messages of the call. And then also that we call this the CDR view, but it gives you just a summary of everything on the call. Basically the to, from, time, when it happened, IP addresses, and then all the traffic information, conversational MOS, listening MOS, packets discarded, jitter, delay, gap, all these types of traffic statistics are shown there, RTP statistics. Okay, again, staying on the data tab and in the CDR view, we're showing now that you have the ability to put that voice file, that bidirectional voice file, or that call conversation that's going on. We're recording that at the probe at that local level there, and we're sending that over to the database. It's getting stored in the database. So at the database, through the web server, through the NetSurveyor web, you can see the CDR, you can look at all the statistics of the call, and you can listen to the call. So that is a feature that we have in there. Okay, so going back here, again, I showed you the multiple tabs that are sort of standard on the product. We're now going to get into the reports tab. And I'm just going to give you a couple sort of system KPI reports. These are just sort of a few basic ones. Call success ratio per time, per day is being shown on the left. Call failure clause, so how many were user busies, how many were no answer. So these types of things can be shown. We have all information. We can show those types of things. We can show the listening MOS. Okay, how many were acceptable, how many were desired, how many, so we've got these thresholds that can be met, and we can show that on a per time basis. You can do that per hour of the day. I mean, it's all customizable, so you can do it per hour of the day, per 10 minutes if you want. You can do whatever you want. Average packet loss. Again, a graph just showing the average packet loss over time. Did you have less than 1%? Did you have more than 1 to 2%? So all of this, again, very customizable. You can set it up the way you want it, and then you can trigger events based on these things. I'll keep moving here. Yes, we're running a little low on time here, but I'll keep moving. We're almost done. The delay of the session request, so when the call is being established, what's the delay? We can show those types. So we can get into the timing on the messages, the protocol messages, and we can be showing those in graph view. Billing, okay. At this point we've got all the information. We can actually show a customer, a network admin, how many minutes were active calls were being active. What's the billing duration? We can show that over time. We can show that for the last day, for the last hour, and so forth. We can count the number of calls that were over 2 minutes or something. And we can, people that are interested in the ISDN messages, this is just showing an ISDN message, but you can actually see the number of messages for the protocol that you're interested in, just to see the distribution of that. Okay, one thing of note here is we've deployed this quite a few times to different customers, and our customers are using it in some customers are using it in sort of a real-time manner. Some are using it in looking at historical data. These particular customers that I'm showing here are actually just setting it up to email a report on a daily basis. So they're not even interacting with the software, with the GUI in any way. We've set it up to just email them a CSV of statistics for their call center and so forth. Or we've in the second screenshot to the right, we're setting it up to send a PDF of a couple graphs for the day. The graph on the right here is showing 8 T1 links, T1 circuits, how many calls were active on each, or how many calls completed on each T1. So it gives you a distribution of where the calls were coming in and so forth. So it's something of interest to the client, and we can show that. And we can set it up at midnight, our software, our NetSurveyor Web, to automatically email this report every day. Okay, so that's what's going on here. I mentioned earlier about NetSurveyor Web, which I've showed you a lot of the feature sets of that. All of the things I've showed you, all of the feature sets, all the reporting, the KPIs, all of that is also available with the NetSurveyor Web Lite. So what is the difference between the two, you may ask? Okay, so what we've done recently here is we've come out with this NetSurveyor Web Lite. And the reason we've come out with it is we built so much feature set into NetSurveyor Web. We want to try to make it very accessible to all customers. Not all customers need multiple probes at different points in their network. So most of the customers that we have is, yeah, I'm troubleshooting. I'm a single point in my network I'm looking at, or I'm in my research and development lab playing around with this protocol. I got a single sort of probe running on this, laptop or something. Well, NetSurveyor Web Lite is able to be on that same system, on that same probe, so it's all local there. And that's the basic idea with NetSurveyor Web Lite. You don't have to have a centralized database somewhere, sort of more cumbersome database sitting in a central point. You can just put it on the same laptop that you're running your capture probe on. And you get all of that information, all of those statistics, all of those KPIs at that point. So you can interface, that could be your interface. So it's a single location. It's lower call volumes, I would say, because you're at a single point. We're not expecting to have 50 probes being reported back to NetSurveyor Web Lite. NetSurveyor Web can handle that. NetSurveyor Web Lite is more of a single local idea there. Everything else is sort of the same on the feature set. There's no differences there. So what I've explained about the call volume and the single location are the main differences between the two. So it's something that if you're a protocol analyzer customer, existing customer, or future customer, just interested in sort of that one probe sitting there, NetSurveyor Web Lite may be of valued interest to you because it gives you that ability to sort of mine the database and figure out, get all those KPIs, get all those statistics in a very easy web viewer or web server, web client interface. Last couple slides here, we threw in at the end. We wanted to focus mainly on our software and the feature sets of our software, the protocol analyzers, the NetSurveyor Web Lite. But as you probably are aware, when you're capturing at these points in the network, you may need hardware, of course, to do that. So we've got a variety of hardware that we've had for years, and we're still developing it. T1 cards, quad T1 cards. We've got an octal T1 card. We've got 16 port T1 card, E1 card, all E1 cards as well. We're big on that area. We get into higher level things. So we got the T1s covered, of course, T1s and E1s, your traditional TDM stuff. We've got T3, E3s, OC-3 cards, fiber, 1 gig interface cards, those types of things. And we're coming out with 10 gig and 100 gig hardware as well shortly. So when you're talking about our PacketScan platforms, we haven't really mentioned PacketScan much, but PacketScan is essentially the protocol analyzer for IP. So with IP, you need an Ethernet interface to capture on. So we've got the ability here to use the Ethernet port on a standard Windows computer, or we have the ability to dedicate a card. And when we dedicate a card, that's when we can get into super high volumes. You can see that on here. I'm not going to get into it too deeply because I don't think it's that important with the protocol analyzers, but just know that if you have a very high volume interface, we have dedicated hardware, dedicated cards here that can handle that and capture. So thank you for your time. I'm looking at the clock here. We're right at the top of the hour, so we did well to get it in within the hour. I do thank you for your time. We're going to open it up now for questions that you have for myself or Savin. Sanjeev will help out with that. One announcement that I will make in the meantime here is, GL is going to be in the near future here, October 10th and 9th and 10th. We're going to be in Amsterdam. And in Amsterdam, there's a show going on. It's called the Voice and Advanced Communication Summit. We're going to be announcing a new product that we have in the voice quality arena. That show is sort of dedicated to the wireless world, I believe, 5G wireless. So we're going to be showing off some of our voice quality testing equipment at that show. I just wanted to make that announcement to everyone.
Yeah, thank you, Matt. We have some couple of questions from few of the attendees. I will read out those. Okay. The first one is, does PDA also store the silence period bytes and any repetition in the bytes real-time speech data?
So I'll take a stab at it, Savin, if you want to chime in. I think the question is about, so if you've got maybe you're talking about like a voice call, and probably talking about an IP call here is what I'm thinking. So we have the ability to record it, store it, sort of as is, we'll call it. So that's as it comes in. So the silence is inserted. If there's silence on the call, there's silent packets, there's silent storage there for us. Savin, you can get into a little bit more detail. We have the ability to do that. We have the ability to put a jitter buffer in front of that traffic and so forth. Can you get into that?
Yes, we can do that. We can even record the silence, and we can even record the duplicate bytes also.
Okay. I hope that answers the question. If that question is related to TDM and not IP, then maybe we'll answer it in a slightly different way. But
yeah, on the TDM side, yes, of course, we will be saving the entire traffic itself from connect to disconnect, like say on the ISDN side. So we don't have to worry on the TDM side. But when it comes to on the IP side, yes, we do save the silence. We do have options to store to inform the application what kind of silence we may get in between the calls, what kind of duplicate, and we can limit that also. And when coming back to the duplicate packets, which means the repeated bytes, repeated packets, yes, we do save all those packets, and we give the information on the duplicated packets also, the number of duplicated packets at the percentage size and at the numerical value also.
Okay.
Okay. Yeah, the next question is, please explain if MOS here takes into account the radio interface degradation. Yes, Omar. Yeah, please go ahead and explain.
Yeah. Actually, I've got a question regarding the quality of service within one trunk. Let's say we have one gateway, one SIP gateway, for example, talking to another SIP gateway, and we have between them some kind of SIP connections, SIP calls, whether on G729 or G711, but whatever the codec is. So here I understand that there is some reports of quality indicators being sent over RTCP, but I'm not sure that this reflects the quality of the call end to end. I mean, for example, we have the caller in one country having bad coverage in radio interface, talking to another guy maybe with using voice over LTE. Okay, right. Here on the SIP trunk, probably the quality is going to be maybe announced on the RTCP as perfect. But
well, you're correct. Okay, so what if we're monitoring at the SIP location? You know, we're not using this. I mean, we are showing RTCP statistics. Don't get me wrong. We have the ability to show that. But what we are showing is packet statistics. So we're looking at the packets. We're looking at, you know, if all the packets within your two SIP gateways there are perfect, which hopefully they are, the quality of that call is going to show as good, very good actually. Excellent. So if the voice has been disturbed way back over at the the far end of your network at the radio interface, let's say the person is completely overdriving the microphone that they're talking into, well, that's going to get disturbed at the in the voice. Okay. So that voice is going to be put onto the packet. The packet statistics are going to show excellent scores because you're not going to be missing or losing packets or jittering packets, but the actual voice, the MULAW voice, the audio or whatever that is, the G729 voice, inside the packet is going to be, is not going to be intelligible possibly. So the point I'm trying to make is that our MOS scores at that IP interface, our SIP and RTP interface there, are based on the packet statistics. Okay, they're based on the packet statistics.
Yes, I understand. Okay, thank you for the clarification. Okay,
now, what you can do, I would like to say, what you can do, I mean, we have the ability to listen in and record those calls. So even though your packet statistics are going to show everything is great, if you listen in real time or if you spot check some of the calls and you're actually going to be able to listen to the conversation and take a judgment for yourself on how, so you have the ability to record those things.
Yes, understand. Yeah. Okay, yeah, that responds to the question. What I was looking for is something end-to-end, trying to, well, if we activate a probe on the radio level, maybe between the media gateway and the RNC or somewhere else, maybe it would give us more information. But listening only on the SIP trunk is going to be given a limited image. Okay, thank you very much. Thank you.
Sure. Well, thank you everyone for attending. We're always excited to give a webinar here once a month. So we will take a look on our website for the announcement for next month's webinar, but we usually do it generally the last week of the month. So in October, we'll have another one on another topic. But thank you for attending, and I hope you guys have a good day. See you next time. Bye-bye.